Hey YouTube, we're live again. What's up? Greg here from GregsTutoringNYC.com. So we're deep into the Form A of the 2023 handbook, and we're going to chug along. So let's do that. Let me get this set up. Bring that up. Get rid of this. Let's see here. Let's make sure we're live. If anybody has any follow-up questions, please email me at GregsTutoringNYC@gmail.com. And let's see what we got going down here. Please like and subscribe. This is a lot of work to do. Actually, I don't think I renamed this. I think I have two 5Ds at this point. This is probably 5E. I will do that right after this. I'm exhausted. I'm literally exhausted. So let's see how far I can get. I'm probably going to go half an hour. If I can go further than that, that's awesome. If I do less, it's still something at all, right? So let's see here. YouTube thinks we're fine. I don't understand YouTube all the time. Sometimes it creates an obstacle for me to even start up. And I have FiOS and a computer that's reasonable enough to pump this stuff out. So anyway, that's the nature of all this. See a few people in the lobby. Hey, yo, what's up? What's up? So let's start this up. We were up to we did 83, so we're up to question 84. And this is just multiplication involving two negatives. So basically what is being tested here is a negative times a negative equals a positive. So if we just multiply those out, we get 6 over 20 divided by 2, we get 3 over 10. So a negative times a negative gives the positive. So we should be getting G. If you'd wanted to, let me just change this for a second. Change the color here. We could have canceled this 2 into this 4. 2 goes into 2 once, and 2 goes into 2 4. A lot of kids don't realize you can do that. So let me just expound that a little further. So if I have A over C times B over D, I can rewrite this as A times B over C times D. I think everybody's cool with that. But then I can re-break it back up to be A over D times B over C. So that means if you can cancel between A and C or B and D, when we flip it, we can now cancel between A and D and B and C. So for that reason, I could have canceled A into D or B into C, even if in the first place. So that's all we're doing here. We're allowed to go beyond the auspices of a given fraction. Okay? Only in multiplication or division. We can't do that if they're being added or subtracted. You might argue, well, there's a minus sign in front of it. Yes, but that's a unary operator indicating it's a negative number. That's not subtraction, right? The plus sign means addition. It also means a positive number. These are two different operators. We normally exchange them back and forth, and there's a conversion we can do. The minus sign works the same way. Minus sign means subtract. Or as a unary operator, it means negative. All right, again, two different things. Again, we can do conversions between them, but they mean two different things. So we're allowed to do the cross product cancel, cross fraction cancel if you want to. Either way, we're getting 3/10. All right, so that was an easy one. That's a given one. They're giving you minimum 4 points by asking you this question. And just be careful with that. Don't forget the minus signs. The answer's not F. The answer's not something worse either. You're also, because this is multiplication, you're not adding them. You're not trying to make a common denominator here, right? There's no reason to bring this into 20ths and then get something like the 7 or whatever. That's not what they're asking you to do here. All right, that's 84, 85. So let me shrink this down. The table shows the income expenses in a bicycle shop on one day. In a bicycle shop on one day. So these are transactions. The description, they paid an employee, they sold 2 bikes, they sold clothing, they bought a new door, and they sold 2 bike parts. So they're breaking it down by income, which is money coming in, and expenses, which is money going out. Okay? So in other words, they sold 2 bikes, they got $800. Okay? They bought a new door, it cost them $900. All right? So with that in mind, let's see what's going on here. Let me try to shrink the slide me more so we can get the answer choices showing at the same time. The sum of all the transactions, the sum was $70. What is the value of P? All right, so what I'm going to do is I'm going to sum up the income. So that's 800 plus the $95 for the clothes they sold plus P, right? So that's the income there. And then the expenses, this is 480 and that's 500. So their expenses are 980. Okay? That means the total for the day, so to speak, was 800 plus 95 plus the P minus 980. That's an expense. That's not money they're going to have. They have to give that away. And they were saying the sum of all the transactions was 70. So equals 70, right? They're talking about the interaction to the day. And you're going to say, well, you subtracted 980. That's not a sum. Well, if I wanted to, I could have stuck a plus sign right into there, right there. So it'll be 800 plus 95 plus P plus minus 980, right? And that's the context of what I just talked about over here about the unary minus and the binary minus, which applies to subtraction, right? The unary one is talking about a negative number. So I can add negative numbers. So I can get the sum of negative numbers, right? I can have -1 plus -2 equals -3. So the fact that it says a sum has nothing to do with the minus sign right there. All right, so let's try to collapse this a little bit. This is 895 plus P. And if I want to, I can add the 980 to both sides. So I'm going to do a plus 980 here and a plus 980 on the right-hand side of the equal sign. So that's going to equal 980 plus 70, right? What does that give? 980 plus 70. We get 0, 5, 1. We get 1,050, if I did that right. Okay, and then to get P, that's what they're looking for. What is the value of P? I'm going to subtract 895 from both sides. That goes away. What I do on the left-hand side, I do the right-hand side. That was 895. So if I do that here, minus 895. This 5 becomes a 4. That 1 becomes a 5. We're going to borrow from here. That's 9. That's 1. This becomes a 5. And we get 1. All right. So the answer we should be getting here is D as in dog, 155. Okay. Because that's when we do the subtraction, that's when we get P equals 155. So this was a bit of busy work. I think the kind of gotcha, if you will, was that sum where you had to realize you were not adding the 980, you were subtracting the 980, and that it makes meaningful sense to add minus 980 or just subtract 980. We know that can work out as an identity where we're just subtracting the 980. Hopefully my voice doesn't give out. We can do a few more problems here. All right, that's all they're looking for. This is busy, so this was important to tally up the income, tally up the expenses, add them up, including the minus 980, and they're telling us that at the sum, adding them all up, was $70. All right. So P is $155, which means they sold $155 on bike parts. So if you go back into the problem and put the 155 in there, right, you should get a tally for the income and subtract the 980, which is what their expenses for the day were, and get 70 back in. That's your double check. Replace P in there, get the tally for the income, subtract the expenses off it, and see if you get 70. Okay, this one involves unit conversions, if you will. They are on the exam. They don't give them too much, but there are metric conversions and yard to feet, and some time conversions and things like that that you guys need to know. Usually, if there's something involving a mile, they will give it to you, but you should know that that's 5280 feet. There's other conversions you need to know. Some they're going to give you fake conversions like logs and DARFs and all these other kind of things they come up with, but that's basically the deal. So Dakota has 4 yardsticks and 2 12-inch rulers. If she lays all 4 out of the yardsticks, both end to end, right? So we can use this left-hand space for that. She lays the yardsticks out, so I'm going to put yard, 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 right? She lays 4 of the yardsticks out, and both rulers. So we have ruler, ruler. What is the max number of feet she can measure accurately at once? Well, it seems to me that a yardstick is 3 feet, 3 feet, 3 feet, 3 feet, and the 12-inch ruler is 1 foot and 1 foot. Okay? So it seems to me she has 4 of the 3s plus 2 of the 1s. Okay? So that's 12 plus 14. That's all that's asking. That's all that's asking. So that would be F. All right. Again, these ones aren't too bad. Hello. Welcome, everybody. I see a few people in the lobby, plus some greeters. If you guys have questions about anything I'm talking about, please feel free to ask. If you want to ask about something I'm not covering, feel free to ask about that, and I will probably address it at the very end. And if you hate a troll, hey, welcome anyway. All right, so let's do the next question. Please like and subscribe. The channel can't thrive otherwise. I'm trying to help you guys. And if you like and sub back, it'll help the channel and other students as well. All right. Okay, so 87 is involving some ratio thingamajiggies. So in a fruit basket, the ratio of apples to oranges. So apples is to oranges is the same ratio as cherries to walnuts. Cherries to walnuts, right? So we're up to here. If there are 6 oranges, so what I'm going to do is I'm going to fill these out alongside of here with the values they're giving in the ratios they're talking about, because they want to know how many apples there eventually are. So apples is going to be to, let's see, 6 oranges, and there are 16 cherries, is to 48 walnuts. So if you notice, it was apples to oranges. I wrote apples to the 6 oranges they told us. And then it was cherries to walnuts. You keep it in the same order respectively. So cherries to walnuts. So we can set this up as a proportion. There's 2 ways to do this. Basically, since it's saying it's the same ratio, right, we could have done something like this. A is to O as cherries is to walnuts. So that means we could write A is to 6 as 16 is to 48. Okay. We run the cross product on that. We get A times 48, or 48A, is equal to 6 times 16. So 48A is equal to 96. And therefore, if we divide both sides by 48, then A is equal to 2. All right, so that would give us that. There is other proportions we could have used here. Taking the test on Thursday, yeah. You guys must be really excited. I'm excited for you guys. So we could have set up another proportion instead of this one. And let me change the color just to be clear on doing this a different way. I could have set it up as A is to C as O is to W. Okay, so let's put the numbers into there. We're looking for A, and the cherries were 16, and that's the same as the oranges. And the oranges were 6, and the walnuts were, where's the walnuts? 48. And if you notice, if we do the cross product, we're still getting 48A is equal to 16 times 6. All right, so we're still going to get the same A equals at the end. Okay, and there's a third way to do this, just by observation. Let me change the color to bring that clearer. Let's use this fuchsia thingy. I think that's called fuchsia. I'm going to notice that this is 3 times the amount of that. So therefore, 6 is going to be 3 times A, and therefore A has to be 2. So in other words, this is times 3. That's times 3. So the obvious way to do is 16 times 3 is 48, and then 6 divided by 3 is to 2. Now, many of you don't know your teen multiplications. This comes up on a lot of standardized tests. That's 16 times 3 is equal to 48. I have a document. In fact, I did a video on it. But if you go to GregsTutoringNYC.com/SHSAT-FAQS. So this is my website, SHSAT-FAQS. If you go to that, there's a video and an associated document called Products to Know. This is part of the products that you're supposed to know. There's a whole bunch of multiplications and fractions and other things that you guys are supposed to know. And by the way, I mentioned unit conversions a couple of minutes ago. There's also a document about unit conversions that you should know as well. It's pretty thorough, probably more than you're going to have to need on test day, but it's stuff you need to use to do all your math through high school and even grade 8. So you guys might as well download a copy and have a great time with it. All right. So that's the other way to solve this. So this has 3 different ways to check. Okay. Also, you could just by observation know that it's not going to be really 38, and when you look at it harder, you know it's not going to be 18. So you can still get down through sanity checking to that 50-50 for A versus B. All right. Okay. Bunch of people in the lobby. What's up? What's up? What's up? If you guys want to guess the answers or whatever, you can do that. I know I'm doing this handbook review late in the year, given the test is in 2 days. But first of all, better late than never. It probably than not. But it also means you guys probably did some of these problems already. But that's the best I can do. I'm only one person, and I'm happy to help you guys out. Okay. Give me 1 second. I've lost the tab. That's 87. Okay, so there's another ratio one here. So let's see if we can make sense out of this. So it says, in the showing of an artist's work, the ratio of the number of paintings, drawings, and photographs. So I'm going to use PAD and PH. So it's saying the ratio of paintings to drawings to photographs, right? We're allowed to have three parts to the ratio. It doesn't always have to be 2 parts. Shown is 3 is to 5 is to 4, all right, respectively. So that's how we know they all match. It says if the number of if the number of drawings was 45, so they're telling us we know that. Okay, what is the total number of photographs? All right. Well, since they're in ratio, we notice that this is 9 times more, times 9. 9 times 5 is 45. Right, again, they give us the ratios, the respective ratios. The drawings, the center one is 45. So we're looking for a multiple at that point. Okay. So that means that this is going to be 36 because this is times 9 as well. And this is times 9 as well, so that's 27. All right. And it was the total number of photographs and paintings. So they're asking us to add these two numbers. Right, so 36 plus 27. We got 3 here, 1, and we got 62, or 63, sorry. So that would be F. That's all they're asking there. Remember, take these one step at a time. I'll get to 9. I'm doing this sequentially so far, so I'll get to 99, probably not today. That is a weird question, and it's just a matter of going through that tree. They were, my wild guess is that they're going to ask you about 99. So just if you don't catch me on the live stream, eventually I will cover that question on one of these, even if it's a video by itself. Okay, and I will try to get it done by test day, which means by tomorrow. So that's not impossible. Let's see, 89. Let me shrink that down slightly. Okay, so for each, this also involves a ratio. So for each 3/8 foot of curtain width, 5/6 yards of fabric is needed to make ruffles. And then the question is, how many yards of fabric are needed per foot? So what they're doing is they're flipping that ratio, right? If this is a rate, so let's just take a sidebar for a second. If I say something, for instance, is 50 miles per hour, right? We would normally write that as 50 miles for every 1 hour. And even though that's normally the way we talk about that, there's also another rate that's true here, that for every hour, the thing in question is going to go 50 miles. Both of these are valid ratios. That's fine, and that's fine. So that's what they're asking in the question. They told us it was 3/8 of a foot to 5/6 of a yard, and now they're asking us how many yards per foot. So all they're asking us to do is flip that. Okay, so now this reduces down to division of a fraction. So let's focus on that part. So we basically have, so what I like to do is take this form here where we have A divided by B this way, and I like to transform it into the A divided by B like that, okay? So if we do that, we get 5/6 divided by 3/8, and we keep seeing this come up over and over and over. That's your keep, flip, change, or multiply by the reciprocal. Okay, so that's 5/6 times 8/3. We get 40 over 18. And if we divide by 2, we get 20 over 9. Interestingly, the instructions say to simplify everything, but they are not giving that choice here. So the answer for this would end up being C. Question number 89. Okay. So again, all they're looking for is that box area to just invert it. They give it as miles per hour in my other example, and they're asking for hours per mile, right? They're both valid rates, and there's nothing wrong with either one of those kind of things like that. If you notice, it's okay that all the answers are in yards because they're asking how many yards are needed per foot. So the ultimate fraction we're going to get at the end of this, theoretically, is 20 over 9 yards over 1 foot. That's what they're asking, per foot, per 1 foot. They didn't give a denomination, so it's going to be 1. All right, and that's why the answer can be yards. The question I get asked when I help students do this is, if we started out with feet and yards, and we inverted to yards over feet, then why isn't the answer yards over feet? Because we metabolized it. That's exactly what we did. So because the bottom's 1, and they're asking what is the numerator, that's the question. How many yards of fabric? The yards of fabric on the top. Okay? Right? And if you wanted to get more specific, this was curtain. Let me change the color of this just to be clear. Because this can get tricky. It's an easy question, but at the same time it's not. This was curtain, right? Versus the ruffles. And basically we converted to the ruffles over the curtain. So they're asking us per foot of curtain, right? So this is going to be yards of ruffles per foot of curtain. So I didn't put those units in because they seemed obvious, but just if you need to keep track of that, that's important for what they're asking. And that's how the answer makes meaningful sense, logical sense, arithmetic sense, all these kind of things like that. So that's number 89. Is there another one on this page? No. So let's go to 90. Okay, so these are our beautiful constant proportionality questions. Let me shrink this down. Actually, I don't even know if it's going to fit this way. Let's see here. So this seemed to have surprised a lot of students last year because they were asking questions like this literally on the exam. I don't know why this was surprising, because this is a major part of grade 7 math. So you guys should not have really had a problem with it. So which straight line in the graph, which straight line is the graph of a proportional relationship? A proportional relationship is y is equal to kx, where k is going to be the constant of proportionality, and the other two are going to be relationship. And if we want to get k by itself, we divide both sides by x, and we get y over x. So you can see that there is going to be an inverse proportion, or every time x goes up, y goes up by the same constant of proportionality. And if that's true, this line here can't be the line. Okay, if that's true, this line here can't be the line they're talking about either. This line here can, and we can check out stuff where we notice that this 4x4 is 1, right? And if we go to 8, we notice that this point here is 8, 2, for instance. So there's a factor of 2 going on there. All right? And that's exactly what we need to do. And furthermore, if y is equal to kx and k is the same, if x is 0, then y must be 0. So any graphing that involves the constant of proportionality must go through 0, 0. So the only one that does that is this line segment TR here, or the extension of it. All right, which would be h. All right, so be careful with this. You guys should understand all the rules, But just remember, one of the ramifications of the constant of proportionality is that it must go, the line that is being discussed through that is going to go through 0, 0 always. So this reduces down to a 5-second question. Okay. For instance, if we look at the graph of 91 on the other side of the page, that is the graph of the constant of proportionality. We can see, first of all, that it's 1 to 1, right? If it's 8 there, then it's that there, right? And it's going up box, it's going up half, cutting that box straight up there. And it really doesn't matter what each axis is saying. We can see that there's a direct thing there. Okay. And in other words, if we went to 10, just to use an even number, we get 1.5 here. If we go to 20 over here, we're going to end up getting 3.0. It's double it. And that makes sense. All right, that's exactly what the constant of proportionality is about. So on that note, we just gave a look-see to number 91. And these are annoying to the extent that it's forcing us to go through every option here. But that's the deal. So what it's saying is, as the ice increases, the what does that say? I can't even read it. The cost increases. I'm going blind. Okay, so as the weight of the ice increases, the cost increases in ratio. So again, if I had $10 of 10 pounds of ice, it would cost me the $1.50. If I had 20 pounds of ice, it would have cost me double the $3. So we can see that that's there. So some friends are buying bags of ice for a picnic. The graph shows the cost of the ice in dollars in relation to the weight. So we just discussed that in pounds. Which statement about the point on the graph is true? Okay, so the point 23, which is the one I'm talking about up here, okay, means that 3 pounds of ice costs $20. No, that's backwards, so it's not A. The point 1, 0.15, which is somewhere around right here, right there. Just to make sure you know where I'm drawing the dot. Means that 1 bag of ice, no, it's pounds, so they lost me there, costs 15 cents. So no, it's not 1 bag, it's 1 pound, so B is out. C, the point 10, 1.5, which is the one I've been talking about, so I'm going to just circle it here, means that 10 pounds of ice, yes, cost $1.50. Dollars, yes. Okay, so it's definitely C. And then just make sure we always want to rule out the point 0.00 means that 0 pounds of ice will be needed if 0 people go to the picnic. No, 0 pounds of ice means you're not paying any money for it, $0. So D is out the window. All right. And by the way, I have this on my errata. I also did an unboxing video, and there's an errata also at that SHSAT-facts from GregsTutoringNYC.com, if you get through that link, where I discuss that they seem to be grouping like questions together on the SHSAT Handbook this year. So they will probably model that on your test day. So if you notice, there's 2 constant of proportionality questions, basically, one after the other. Completely different oriented stuff. For instance, like 90 is not the same question as 91, but the grouping that, if you notice from some of the others we covered, is kind of the same thing. Again, another graphing. And if it's not about the constant proportionality, at least they're putting graphing questions next to each other. All right. So we're at 92. Let me see how we're doing on time. All right, we're about 40 minutes. Let me see. I'm getting exhausted. I can't see anymore, and I can't talk anymore, and I'm about to pass out. So let's see how far I can get here. All right, so we have another illustration. The x-axis is time in hours, and the left axis says keystrokes. That does go through 0, 0, and we can match up stuff. What I often like to look for is where the line crosses something here where there's a dot there. So that seems to happen. What does that happen? Maybe right there. So at 1,7,000. Now they may not ask us about that. So let's kind of see what's going on here. And it says information entered. So apparently they're logging people's keystrokes. So let's read the words. A clerk enters info at a computer. The graph shows the relationship between the time and hours and the number of keystrokes the clerk makes. Okay, what is the meaning of the point? 1.5, which is over here. 10,500. So that's going to be right there. Okay, so that's 1.5 comma 10,500 in the graph, right? So it should mean after an hour and a half that somebody did 10,500 keystrokes. So let's try to find the answer that seems to say that. So E, the clerk makes 10,500 keystrokes each hour of entering information. No, it says an hour and a half here. So E's out the window. That's definitely not it. F, the clerk makes 10,500 keystrokes in each 1.5 hours of entering the information. Yes, I originally said it in the reverse that in 1.5 hours, they make 10,500 keystrokes. But just like the miles per hour example on the other question, we can flip it. So if 1.5 hours means 10,500 keystrokes, then 10,500 keystrokes means 1.5 hours. So the answer there would be F. And let's just rule out G and H for sanity purposes. The clerk makes 15,750 keystrokes in an hour. No, first of all, the hour thing is down where I was pointing before, and that seems to be 7,000. So G is wrong for a few reasons. And then 8 says the clerk makes that many in an hour and a half. No, well, that's an hour again. It's not the hour and a half. So that is also out the window. All right. Let's see what else we got here. Let me pop this up because I cannot read this anymore. So when the 3-digit whole number 2, 7, something, I'm going to put X here instead of the question mark, is divided by 3, or that 27X is divided by 4. The remainder is 0. What is the missing digit? So this is annoying. So if we do we're going to try 270. 3 goes into there. Does 4 go into 270? Right? We can half that and get 135. Half of 135. Right? I'm working on this that 4 is the same as 2 times 2. So if I divide the 270, I get 135. And I can't have that without a remainder. So 0's out. All right. 2. If I have 272, doesn't work for 3 because we get not 9. 9 goes into 27, but then we get a remainder. So 2 was out the window. 3, if it was 273, 3 does go into there. But how about 4? We have 200. Wait, 200. 273. So if we divide that by 4, we get 6. That's 24. We got 3 left over. And 4 does not go into there evenly without a remainder. So it's not 3. And that leaves us, if we did this right, that we're going to get 276. And I can either divide that by 6 or add up the sum of the digits, which is equal to 15. And I know 15 has that property, so that's good. But we can actually go do it if we want. Because 6 needs to be divisible by 2, it's even, and also needs to divisible by 3. That's why I'm doing that. Anyway, 6 goes into here 4 times. That's 24. We got 3 left over. And then 6 goes into 36, 46 times altogether. And then we can do the same thing over here. 4 goes into 276. And we can use division by 4 rules, but that normally uses multiple digits, and I personally don't like working with that. Anyway, this is still 6. We get 24, right? Sorry, that should have been 276 here. 24, we get 3 left over, and then that would be 9. So the only one that works with both. This is a time waster question. Can't really be optimized too much unless it's blowing my mind how to do that optimization. And then just double check your divisors to make sure that truly is 6 when you finally get that answer. Let's try to do maybe 1 or 2 more, and until I conk out anything that's going to start looking wicked, which is probably this example. So food consumption of the average American per year. So they break it down into various categories. For instance, cereals 10%, milk and egg is X%. So that seems to be kind of a heads up there. Total consumption is 1840 pounds per person. So it seems to me that if that's the total consumption per person, and for argument's sake, if meat and fish are 10%, that means the average person eats 148 pounds of meat and fish. Okay. Cereal is also 10%. So the average person would eat 148 pounds of cereal. And some of the other ones we can do, basically, if it's fruit and vegetables, we need to be getting 38%. Of means multiplication of the 1840. If that's not what they're asking us, I'm not going to compute that. I'm just trying to give you guys kind of a heads up about how to use the data that they're providing here. So, all right. So based on this circle graph, how many pounds of milk and egg does the average American consume each year? So it says milk. Where's milk? Milk and eggs is down here. That's X%. Oh, thank you, people. So that means we need to add up all the others and and whatever's left is going to be the milk and the eggs. Okay. So let's just start writing that out. So we have 38 is the fruit and vegetables, 10 for the cereal, right? So far we have 48. Okay. We're going to add the 10 for the fish. So now we have 58. We're going to add the sugar. That's 8. So now we have 66. And then we have the fat and oils, which is 4. So then we get 70. Okay. So all I did was I went around this clockwise and add those numbers up. I would double check this by going backwards and adding the numbers up backwards just to see that you get that 70 again. That means milk and egg is 30%. All right. We already know that 10% is 184 pounds. So really what we need to be doing here is just multiplying this by 3. 4 times 3 is 12. Carry my 1. 8 times 3 is 24. Add my 1, 25. 2, 5. So the answer, there better be an answer choice under here, 552. It is. All right, that's all they're looking for there. Welcome again, folks. Please like and subscribe. I see a crowd in the lobby. What's up, everybody? All right, let's see here. We're going for about 50 minutes. I normally try to make these under an hour. I really, literally can't see anymore. So let's see how far I can get. I'm bleary-eyed. I've been doing this for hours. So let's try 95. Maybe we'll make 95 the last question. I'm not sure. And we can at least make some progress there. Okay, out of 2,000 high school seniors, 191 were enrolled in the Honor Society. So normally we'd have 191 out of 2,000. Okay, I don't know where they're going with this yet, so that's what I'm going to write. Let me put the units. So this is honor society, and this is total. Okay, what percent of the entire group of 2,000 seniors were in the honor society? So that's it. That's our fraction. So basically, they're asking us to find what percent. Percent means over 100. So we can do this and do the cross product, or we can just do the division there, 2,000, because we're gonna have to end up doing that anyway, even if we do the cross product. 2,000 goes into 191, and I see they have up to 3 digits here in some of the answers, so I'm just going to put that down here. Although once we match one of these, we kind of should be all right. So 2,000 into 1, no. 2019, no. 2,000 into 191, still no. So I put 0, I bring up the dot. 2,000 into 1910, still no. All right. So then we've pretty much, well, actually we haven't, because we need to get to see where we're at here. So 2,000 into this 19,100. So that seems about 9, because if we did 10, then it would be 20,000. And if we did times 9, we get 18,000. Right? So we get 9 there. And we can put 18,000 here. And if we do subtract that, what do we get? 900? We drop down that 0, and then we get something like 4 or 5 out of that. Let's see, 4 is going to give 8. And then we're left with 1,000. Yeah, and we get 5. I believe this is right numbers. I'm flying by the seat of my pants right now. Anyway, that's what we're going to get there. Now, this is a decimal number that we have like 0.09 something. So this is percent. This means 0.9 over 100. So the only one even close to that is choice number C. So I said 9.45. It must have been 9.55. All right. And on the real test, I would make that calculation better. Let's see. Where did I make the mistake? Yeah, there was supposed to be a 1 here. I just did it. I did it as if it was 19,100 from 18,000. Sorry, 19,000. Anyway, I definitely screwed that part up. It should have been 1,900 at that point. All right, and that would have given us the 5 for sure. All right, let's see. Let's try to do one more. And then I'm going to call it a night. The number of visitors to the Brookside Zoo. I'm going to look for the illustration first. There is a 2x2 table split into males and females versus children and adults. I don't know where they're going with this. Sometimes they may ask us to like total the number of children. In that case, it would be 700. Okay. Or they may ask us, for instance, to add the males. In that case, it'll be 570. All right. I don't know where they're going with this. So the table above shows the number of people who visited the zoo in one day. Awesome. The larger of the 4 groups made up what percent of all visitors that day? All right. So we kind of do need to figure out which group was the larger of what was going on there that day. So it looks like the adults is 500. All right. right? There was 360 plus 340 children, so that's 700. And there's 210 plus 290 adults, so that's 500. All right. And it says the larger of the four groups, so this is the larger of the four groups, the 360. Makes up what percent of all visitors on that day? All right. So all visitors is 1,200. So just like the previous example, this is a percent question. So it becomes down to 360 over 1,200. Okay. I can cancel the zeros out. Divide the numerator by 12, so I get 3. Divide the denominator by 12, and I get 10. So my answer is 3/10, which is the same as 30 hundredths. So normally I do strike out those extra zeros, but in this case I had to add them back over here. All right. So the answer is E. All right. All right. We're going to call it a day. Anybody have any questions? Any questions? Last call. All right. Please like and subscribe, people. This is a lot of work. It takes me a lot of time. And you see me doing this at the brink of exhaustion. I can't even read the questions anymore. All right. I'm going to probably maybe do some more tomorrow morning when you guys are in school. And certainly again tomorrow night if I can get some time. If not, I will continue after Thursday because there's a lot of students taking the test after Thursday. All right. Peace, y'all. Please like, subscribe, share, comment, jump up and down and scream and yell. Yay. Okay, bye. Peace.